You know what's crazy? Solving this problem is so simple. You don't need a calculator, no logarithmic expressions, none of that. Throw it out the window. You're a number ninja who's subscribed to my channel, and I know you care about elegant and quick tips, so let's get started. To save yourself time on your next exam, when you see a problem like this, first check and see if the terms have something in common. Well, 9, 3, and 36 here all have a common multiple of 3. So why don't I start by approaching this problem where I represent each term in terms of 3's? So 9 obviously is 3 squared, right? So I'm going to write the left term as 3 squared all raised to the x plus 1. And the middle term here, it's already 3. And that's its reduced form. So I'm just going to leave it the way it is. And for 36, you might be able to decompose this mentally in your head even quicker than I did. But for some of you that are following along, it might be helpful that I break this into smaller chunks. So let's start by decomposing 36 into simply 3 times something else, which is 12. And I want to then take that a step further. On the right-hand side, when you have 3 times 12, well, 12 itself also has a factor of 3. It's 3 times 4, right? So we can actually rewrite 3 times 12 as 3 squared times 4, but I'm going to actually do something kind of cool here. Instead of 3 squared times 4, I'm going to write 4 in terms of 3's, the same as 3 plus 1. Nothing wrong with that, right? And on the left-hand side, the 3 to the 2x plus 1 term remains unchanged, and I'm going to distribute 3 squared all to the x plus 1 by multiplying that power of 2 times the expression x plus 1, giving me 3 raised to the 2x plus 2. Easy peasy, right? The next step I want to do is, when I work on the right-hand side, I'm going to distribute that 3 squared term by multiplying it by the 3 and following that by adding it to the result of multiplying 3 squared by 1, giving me 3 cubed plus 3 squared. So the right-hand side now is fully written in terms of 3's. Now on the left-hand side, I want you to notice something. 2x plus 2 and 2x plus 1 have something in common. Well, it's 2x plus 1, but the left power happens to be 1 more than the right. So I'm going to use another weird trick here, and I'm going to write 2x plus 2 as the same as 2x plus 1, and I'm going to group that left 2x plus 1 part in such a way where it's a little bit more clear and obvious that it's similar to the other term's power, except that here we're adding 1 more to it. And when you look at this equation now, 3 raised to the 2x plus 1, all plus 1, plus 3 to the 2x plus 1 equals 3 cubed plus 3 squared on the right. Now the left and right have something very interesting in common. Notice on the right-hand side, when you compare 3 cubed and 3 squared, the left term is also 1 more than the right term. So instead of having to use any cool fancy arithmetic here using logarithms or anything like that, by inspection, we just saved ourselves a ton of time. And if you found an even quicker way of doing this, leave me a comment below and tell me what you found. But basically what I can say here is, looking at this, if we know on the left-hand side of the equation, the power is 1 more than the term to its right, and similarly on the right-hand side, I can safely say then that 2x plus 1 here must be 2. And when you solve this, ta-da, you get x equals 1/2.